Well, hello friends, welcome back to the program. Today we are going to work on the image viewer application in Serenity, and the goal is to sandbox it because already today we sandbox image decoding when it happens in the browser. So when we view images on the web like this one right here, it is actually not decoded in the browser process, but rather it is passed to a helper process called image decoder. And image decoder runs with a reduced set of pledge promises. So it's standard IO, receive and send file descriptors, and it has no file system access, no process management access, very, very limited what it can do. And really an ideal situation for decoding untrusted binary data like images. But if you're looking at a local file, then we don't really do anything like that. So if I open up this image here of Buggy, for example, then the image viewer just parses this PNG image in process. And in this case, it's an image that we control ourselves. But what if you've saved a file from the web, right? Just because you download it doesn't mean that it's suddenly safe. So I think it would make sense that image viewer would take advantage of the sandboxed image decoding mechanism. And really, I feel like for any image that you load on the system, maybe excluding stuff that we know to be trusted, like system bitmaps and stuff. But for most images that you try to load, we should probably use the image decoder service. Certainly for things like thumbnail generation and stuff like that. Although we're not going to go into that specific area today. We're just going to work on image viewer and port it to the image decoder service. So let's get cracking on that. And before we do that, let me just grab a cool picture. And which one is the coolest? All right, hold on, wait. I should search for the coolest picture. Ooh. All right, well, this is a cool picture right here. Batman stabbing a shark with a lightsaber. I can get behind that. So, let's call that bat.jpg. And yeah, let's use that for our test. And actually, before we do anything else, let me see that we can actually decode it. It doesn't work. It doesn't even say why. That's unfortunate. Well, it's probably some issue with the JPEG decoder, that it doesn't support this or that or whatever. So let's just be a little bit lazy here and turn it into a PNG. All right. Should probably do some more work on the PNG or on the JPEG decoder at some point. Yeah, so here's our bat. I feel like maybe I didn't clean up the JPEG one. Yeah, there we go. Okay, now that we have a cool picture, let's see about getting the image viewer to decode it out of process. So the first thing we're going to want to do is link image viewer, the application, with libImageDecoder client. It's a bit of a mouthful, but oh, look at that. A bit of a mouthful, but I think that's just what the name is. So we're just going to tolerate for now. And then we need to see, where does it actually load something? So when you open a file in image viewer, then the open action is used. And in the callback, we open a file picker and get the value and then call load from file. Sure. Load from file is in view widget. And what it does is, so this will mmap the file at the path. Sure. And then create a graphics image decoder for that data. So this is the part where we want to not do this in the process. So we want to delegate that to the image decoder service. And at this point is where we would call out. So let's see, lib image decoder client. I'm just gonna bump that. Okay, load from file. Okay, so we have the mapped file. Then let's see what API that thing has. So image decoder client. We'll just make one of those. And what can we ask from it? Decode image. Perfect. And we just have to give it a byte buffer. So we can do that. We will give it a byte buffer. Byte buffer is actually a little bit of an unfortunate API here, because if we look at image decoder server, oh wait, hold on, it actually takes an anonymous buffer. Yeah, because what I really would love to pass here is just like a span, right? A span of the bytes, and then have the IPC system take care of that. Or is that really what I want? Decode image takes a byte buffer. Well, okay, let's not overthink it right now. We don't have to optimize this thing for minimum mem copies at the moment. Let's just get the thing up and working. So we'll tolerate this. We will do a byte buffer copy of mapped file bytes. Can we do that? Cool. Decoded image is that. Okay, so if decoded image has value, then what do we have in the value? Frames is animated a loop count. Okay, all right. Interesting. So I guess we want to hold on to that decoded image in mbitmap and whatever, because we do allow animated GIFs. I think maybe animated GIFs is going to be the tricky part here, but we can definitely get rid of the image decoder because we don't want that in our class. Everything else we can hold on to, I think. So if this fails, let's say, let's exit out early here somehow with some grace. So show error. Sure, yeah. And then decoded. Then value, sure. Bitmap, cool. Is animated, we get here, sure. And decoded image, the frame count. So the animation frame count will be in decoded image frames size instead. That's fine. And mbitmap we've already assigned here, so that part is fine. Okay, and then the animation logic. So let's just comment out the animation logic for now, and then we can come back to it once we have static non-animated images working. So let's see. Okay, well that just worked. amazingly. That worked a little too well. Did we even rebuild? I guess we did. I'm suspicious. Why does it work so well? Let's see if we actually get an image decoder program here. Image viewer, did we get? Okay, I'm suspicious. So I guess it exits after it's done with the decode, which is fine because we only need it for one-shot decode anyway. We don't need it to stick around, but I feel like maybe it would be cool to just say something like image decoder, hello. Because this is silly, but like now this was so easy that I don't quite trust it. All right, I guess it does. Okay, fine. I guess it did work. It did just work. Gotta stop being so suspicious of my code. Look at that picture, holy moly. Okay, so, oops. So the application is a little bit sluggish actually, but that has nothing to do with the decoder. I mean, the decoder is already gone. I think it's just we're not super great at handling this large bitmap. Yeah, anyway. But I guess that's totally fine. So that's super cool. Why did that work so well though? And oh, and also what would happen if we would crash? So what if, let's see, when we handle the decode image message, what if this is so silly, but can we get a random number here? Random, get random u8. If it's less than, I don't know, 20, or say 40, then let's verify not reached so that we'll crash. And then basically the image decoder program will now crash randomly sometimes. So if we run it a bunch of times, there we go. Image decoder has crashed, and we just get fail to open bad PNG. That's pretty rad. That's pretty rad. Obviously, it would be better if it would report something that like image decoder service crashed while parsing or whatever. But this is definitely an improvement over the image viewer program crashing. So now the image viewer can still survive. This is the last. Yeah, okay. So the UI of image viewer is a little bit awkward. And certainly stuff like when you open a file that fails to load. Oh, that was weird. Try to open a README. He didn't like that at all. Image viewer. Load from file. Wait, what? Load from file. What is the assertion that fails? The verification thing? Vector? Wait, I'm not in the right file at all here. I'm in libgui. Okay. Hold on. Load from file, blah, 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 blah. some vector access was failing. Oh, I guess it's this one right here. Oh, that's so weird. So I think if you try to load a readme.md, the fact that that appears to have succeeded is kind of strange. Although if you get 0 frames, then I guess we could also consider that a failure. If there are no frames in the returned image, interesting. I think if there are no frames in the returned image, we shouldn't consider that an image worth returning. So I'm going to go ahead and say if response. Now I'm fixing the libImageDecoder client, because the image decoder loaded a markdown file and then said, oh, this is fine. This is totally an image. It has 0 frames. I think that's silly. So we will do this. Actually, we'll do that here after response actually exists, and say, oop, yeah. Right, yeah, that makes more sense. Also, this UI is a bit goofy that you get the message box first, no image viewer on screen yet, and then image viewer comes up in a sort of empty state. That could definitely be better. Like maybe no message box at all, but rather something like this interface, but with a like a failure icon in the middle, or I don't know exactly what it would be like. Sort of like you know that when your browser tab has crashed and you have this sad tab face in the middle, but not quite that, you know, condescending, but something in that vein. Okay, so let's commit this fix first of all. No. See, okay, so zero frame decode decodes with 0 frames. Decoded images with 0 frames. I'm not successful. Yeah. Previously, you could pass anything to a text file to image decoder and it would succeed in decoding it and give you back a 0 frame result. Let's consider that state a failure instead. Yeah. I think that makes sense. And this is just the random crash that I introduced just for testing, so we definitely don't need that. So let's not commit anything else of this that we have so far. Also, I think here, the fact that I'm doing a copy here is kind of gross. So I'm gonna go ahead and say, fix me, find a way to avoid the byte buffer copying here. The memory copying here, yeah. Okay. Connect to spawn a new image decoder service process and connect to it. Yeah, I love image decoder. This is so such a sensible design, I think, to just let's just not trust images and throw them into a sandbox and deal with them there. That just makes so much sense to me. So, okay, so I guess now we gotta do something about animations. So we have at least one animation in the system. file flying animation, right? So I'm just gonna put that in my home directory for easy access, and then we will try to make that work as well. So right now, nothing happens, but let's make something happen. So I guess it's this animate function right here. So it was assuming that we would still have the image decoder, which we don't, which means that we do have to hang on to all the frames that we got. But we can do that. We'll just have to stash these somewhere. So a decoded image is just this stuff. Let's see. Let's just go ahead and store that. So is there a forward? No. Okay. So we'll just include that from here. Client H and bitmap. We will store image decoder client, decoded image. Maybe we'll put it in optional. Yeah, that makes sense. Okay, and then we'll do this. We'll release it into there. Okay, so now we have all that stuff lying around. Of course, it will be in an optional, so we have to access it like that. And then when we animate, wait, who calls animate on timeout? I feel like, is somebody gonna stop that thing? mtimer stop. Yeah, we should probably be a bit careful with that. So if we don't have decoded image anymore for whatever reason, then we should definitely not try to animate it. So let's just say that just to be safe, and decoded image frames size. Yeah, just translating this thing to this other way of accessing the information. There we go. Set bitmap. What's wrong with you? Oh, this is a U32. Okay. All right. Well, we'll just do a little cheesy cast there. No big deal. So the mismatch in terminology here is kind of, I don't love that. Like the fact that the libgraphics in-process implementation and the image decoder service implementation, they have slightly different names for the same concepts. I think that's something we should go and improve later, and just unify things, because it is worth it to unify things and use identical terminology. And there are really no excuses within a project such as Serenity to not do that. So definitely something to do. Okay, so failure Y. Oh wait, was that a random? That's my random crash. Okay. Oh, and now it just works instead. There's that flying GIF. We have some other GIFs as well. So graphics. We have the download animation. Yeah, that random crash feature is kind of stupid. But yeah, this totally works. That's so cool. Right, so the way that GIFs are decoded now is that we do a one-shot decode. So we decode all the frames in one go in the image decoder service, and then we just yoink them all over to image viewer, and we don't do incremental decoding. So if you have a gigantic GIF, it's kind of a flaw in the way it works right now. That flaw existed in the single process version of image viewer, and it now continues to exist in the multi-process version. There is the problem that if you have a ginormous GIF that has just very large frames or very many frames, it will use a lot of memory, and that's probably something that we should look into fixing. Although it's not an entirely easy problem to solve just because of how limited the GIF format is. And I know that a solution that some software does is that they translate GIF animations into a more compressible format, like I don't know, like H.264 or like some video format, right? And then they store that instead, and it has much better memory usage characteristics. But let's not worry about that right now. Right now, we just wanted to sandbox this thing, and as we have been getting a few random crashes, we know that the sandboxing works. So pretty sweet. That's fantastic. So let's see. Let's just get rid of the random crash first of all, because that was silly. And then what are the changes? So let's do a mini code review here. So now we will simply spawn a new image decoder service process. This is done automatically behind the scenes by instantiating a image decoder client. And then we will ask the client to decode this file that we have opened. So we just shovel all of the bytes from the file we opened over the IPC socket to the other side. And one way to improve the architecture here could be, for performance to improve the architecture could be that instead of sending the bytes over, we would send a file descriptor over. So we could add a different API, like an overload essentially of this API, or a different variant that takes a IPC file instead of an anonymous buffer. And that would then allow the receiving end to mmap that file descriptor and load the image that way. So there would be no copying. I think that would be a pretty good architecture. And something that we could do, but I'm not going to do that now, but it would be cool. Right, and then after that, it was really just about changing the way that we access the decoded image, because we're no longer getting it from a graphics image decoder, which we used to have, but now we're getting it from the libimage decoder client decoded image struct, which is what we get from this API right here. So I think the last thing to do is maybe stop including image decoder stuff in the view widget, I was gonna say, but it's already not here anyway, so that's a bit weird. That's fine. Oh, here it is. Okay, so we'll get rid of that include. I think that's fine. Maybe this include as well. Yeah. Cool. Very, very nice. Okay, so image viewer, sandbox, image decoding, using the image decoder service. Instead of parsing potentially untrusted and, let's say untrusted and potentially dangerous or malicious image files in the image viewer process. Great process. Take advantage of the image decoder service that we already have on the system to sandbox the heck out of this. Yeah. Sandbox this. We don't need to say heck. Come on now. The heck is implied anyway. Sandbox this operation, or sandbox decode. This prevents bugs in the image decoder, in our image decoding libraries from being exploited, or from being used as an exploitation vector and viewing image files. Yeah. An image viewer. Cool. I really like that. That's really cool. That's fine. I'm aware of the fix me. So let's just verify that that if we go to a file that has a bunch of icons, for example, and we, oh, what happened there? Okay, wait, I don't know what happened there. What the heck? Res icons. Okay, well, I don't know what that was, but that was not my fault. I mean, probably it was my fault, but I don't think it was something that we broke now. So just like scanning through all of these super fast, you don't notice that it's spawning a bunch of new image decoder processes, right? So we'll just set that to update quickly, and then yeah, you sometimes, if you're fast enough, then you can see image decoder popping up here, but they disappear very quickly. So I think that's really cool. It doesn't feel like it matters at all that we spin up a new process to do this. It's super fast anyway. Cool. I'm very happy with this. I think this has been a great architectural improvement to the desktop system. So thumbnailing is something that we should also do in a sandboxed way, for sure. Like the way that these PNGs here are thumbnailed, for example. We should probably figure out a way to do this in the image decoder service instead. But that would require a bit of finesse because thumbnailing is currently done on a background thread in File Manager. And yeah, we need to figure out some ways to deal with, or figure out how to architect that. But today we have done what we set out to do, and I'm happy with that. So this will be the end of the video. So thank you very much for checking it out. And I hope you saw something interesting. And I guess I will see you next time. Bye.